Okay, my friends, so let's get into, let's fix that typo too while we're at it. Variation in the empirical rule. Okay, we did this a little bit in class this week, but let's look at it more here. So we got ourselves a data set of patients at a clinic, which is awesome. I want to go ahead and download it so I can actually open it up and play with it, not on Jesus motherfucker. Start this whole quiz again. Okay, my friends, so let's get in here and take a look at this empirical rule quiz. We looked at this a little bit in class together, but this is a fun, like, deeper dive into it. We did a little bit of it in class, and then we Googled, which is always good. But it's always nice to, rather than just looking something up and seeing that there are web pages attached to it, it's nice to actually see it with your own data analytics as well. So as far as the spreadsheet goes, here are the patients in the clinic. There are a lot of them, and for some reason that row is taller than the rest. Whatever, I guess it's fine. I asked you to make a histogram first, and I know we skipped over question 1. We'll do that in a second. And I'm not going to spruce it up all that much with a title, an axes. But you've got ages of patients across the bottom. Your title can be anything along the lines of, ages of patients at a clinic. And then vertically, you've got the number of people in each bin. I'm going to go ahead and put the data labels on just because I always like doing that. Okay. Oh, what the hell? Let's put labels on. Let's put a chart title and some axis title. So the chart title is ages of patients at a clinic. Okay. The horizontal axis is going to be years old. And the vertical axis is going to be number of patients. There we go, number of patients. Okay, so question number 1 said, when might you not trust an average? And this is not a case where you wouldn't trust it, which is kind of a weird way of saying that you would. If you did the Facebook quiz this week, the Facebook quiz definitely is one where you probably should be distrustful of the average because you've got the unbalanced asymmetry of the skewed data. This data here is, it's not perfect. Not perfect, but this data right here is a nice symmetric bell curve. So that means the average is going to be kind of close to the middle. Let's find the average actually. Equals average. Average of all these numbers. It's at 40. Yep. And I kind of went like this kind of cavalierly with my mouse. And yeah, that's about where the average is. As a matter of fact, I think in the video that I made for this, I goofed around until I got the average to sit on one of the lines, and I forget now how many that took. Is it 13? I don't remember. I'm going to keep goofing around until that's pretty good. There we go. That's pretty good. So 40 is going to be right about here. Right about there. Sick. Okay, so that's the average. That's the mean. And then we got the standard deviation. We'll do that too. Equals standard deviation of all these numbers. So on average, we deviate about 10 years from the average of 10. So there we go. So on average, they're 40 years old, and they deviate on average 10 years from that average. Excellent, excellent, excellent. Now, I showed you in the video how to calculate the percentage of data that's within a certain number of standard deviations, and I believe on the quiz, let me go back and look at it again. I think I have 2 standard deviations of the mean. Okay, 2 standard deviations. So for 2 standard deviations, I got to start at 40 and go out 2 times 10. So that's just going to be equals 2 times 10, which is going to be 20. I might actually round to 19 now that I think about it. Yeah, it's going to round to 19 because the 10 was actually rounded to 10 from 9.6. I'm just going to go ahead and call it 20 if it's okay with y'all. Keep the rounding consistent at least. Okay. So we got to go up and down 20 from 40, which places us at 20 to 60. So we got to get the years between 20 and 60. And if you go 21 to 59, I can live with that too. All right, so we know, I think I did in the quiz, I colored the bars. So I know that one definitely and that one definitely are within. I think this one's definitely within. And this one's definitely with, actually, a lot of these bars are going to be definitely within. Oh, we actually got, this is going to come off pretty nicely. All those bars, and that goes right up to 60. So that's awesome. We get all those for free. And then we got to go down to 20. So 23. Okay, so now, and then we're down here, but we're not going to take all the data in that bar. We're only going to take 80% of it, right? From 19 to 23. 19, 20, 21, 22, 23. Although we'll leave 19 down here. So we'll take 25% of it. So we take 30, 52, 83. I better do this. 30 plus 52 plus 83 plus 79, excuse me, plus 92 plus 95 plus 65 plus 46 plus 15 plus 3/4 of that 17 down there. And that gives us a whopping total of 570, if you want to, 570 data points are within 2 stadives. Within 2 stadives is 570 data points. I love that. 570, okay. Now, as far as the total, or the number of data points, which is n, we can do that a couple different ways. We can hit B. It shows 590 down here in the count, but that's actually also counting the words ages of patients. Yeah, Excel doesn't differentiate between numbers and text. So we got a 589. I'm sure there's a count command I can use to do this. So what percent is going to be within? Well, that's going to be the 570 divided by that 589. And that is just, ooh, it's rounding it to 1. Let's not call it 1. Let's give it some decimals. That's about 97%, it looks like. Roughly 97%. And that, your answer might be a little bit different than that, depending on where you drew your dividing lines on the bars. But I got about 97% of the data is within 2 standard deviations. Beautiful. Let's go back to the quiz. And then, oh yeah, that's right. I forgot about that. On the spreadsheet, I set up a simulator that randomizes bell-shaped data. So in other words, you can create a new batch of 40-year-old people, well, on average, that have a standard deviation of 10, and there's still 589 of them in this line. And you can see that every time I re-randomize, I still get the same average of 40 and the same standard deviation of 10. Wow, look at that one right there. That's like a really pretty bell curve. But most of them aren't. Most of them look a little bit, that's a little bit of skew to it. That's a little bit of, actually, you know what's fun? We can actually learn this here. There's a command called skew. I don't get into it in 243 all that much because the interpretation of skew is a little bit hard. Negative skew, like this one is up here, implies that the average is a little bit left of where the median is, which means the data is a little bit heavier on the left side. There's a positive skew. That data is a little bit heavier on the right side. There's a negative skew, a little bit heavy on the left side. You can see by these tails over here. There's another negative skew. There's a slightly higher positive skew, probably because of these outliers over here. A skew of 0 would be perfectly symmetrical. And you can see that you don't get that. You never get perfectly symmetrical data if you do something's wrong. So what you're seeing here are, and I don't want to get too much into skew in this quiz because A, I didn't talk about it in the quiz, but also B, nobody seems to agree on what the skew, how skewed is too skewed, if that makes sense. So I just like looking at it as if it's negative, like that one is, that means it's got a little bit more weight on the left than the right. And if it's positive, it's got vice versa. So what I'm really interested in, though, are these percentages that are down here. And you'll notice that as I regenerate, with different averages and different standard deviations, this is keeping track of the percentages. And you'll notice something. Within 2/3 of a standard deviation, which is this 0.67, notice what these numbers are bopping around. They're bopping, some of them are just below and some of them are just above 50%, which is exactly, within 2/3 of a standard deviation is almost exactly 50% of the data. Within 1 standard deviation is about 2/3 of the data. Now don't get confused. This is 2/3 of a standard deviation. This is about 2/3 of the data. I believe the closer number is 68%, but I always round that off to about 2/3. This number here, 2 standard deviations, is going to be just shy of 95%. And 3 standard deviations, as you may have noticed down here, is sometimes 100%, but sometimes there are some data points that escape even 3 standard deviations. But it's very close to 100%. And that's what I wanted you to do down here, which was, you know, this is about 50% of the data. This is roughly 95, which is pretty darn close to what you got back in question 3. And this is roughly almost 100%. And we did Google in class about what the empirical rule is, which effectively tells you 2 things. It tells you in a bell curve that you're going to have these percentages. It doesn't include the 2/3 of a standard deviation, which really kind of makes me sad. I think that's a very useful number, where half of your data is. But it tells you that within this number of standard deviations, you have this percent of data. It can also be used backwards. You can check the data within certain standard deviations to decide if something is bell curved enough. All right, my friends, we'll talk to you soon. I hope that helped.